The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Hey Ben, the community had asked that you make a portable of this.
A portable version. Of
Yes.
course they did. I have a few issues with this.
What issues do you have with making that
The board's
portable?
kind of big, and also it requires HDMI. It's really hard to find small HDMI screens.
Yes.
The smallest you might find is like 7 inches, like on one of our video monitors. I think it'd be better to use a Raspberry Pi.
Good thinking.
Got a bunch of these A pluses laying around, which are kind of like the A, but they have the same amount of I/O as the Raspberry Pi 2. So I've got an idea. It involves config files and LCD screens, but I think we could probably direct drive a piece of glass like this with the Raspberry Pi.
Really?
All we would need is a header adapter for right here. So let's do this. Could you remove all the parts from one of these Raspberry Pi A's to make it as flat as possible?
Sure. Remove the header, the display interface,
Pretty
the
much
camera
everything but
interface.
the power port.
Okay,
Yep. Yeah,
yeah.
get rid of the HDMI as well. So yeah, you do that, and I'm gonna get some other stuff prepped, and then we'll show you how to attach an LCD directly to your Raspberry Pi using the I/O. No HDMI adapter required. Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, I have this 480 by 272 TFT LCD. This is actually pretty much the same kind of screen that was in the original PlayStation Portable. It's pretty common to find these. I might just wire it up as 16-bit color, which would be 565. 5 bits of red, 6 bits of green, 5 bits of blue. So whenever they have less bits, they always give the extra bit to green because humans can see the color green better than any other color. Anyway, I've got this piece of plastic here, and I think what I'm going to do is cut it down to fit on the back of this so I can attach components directly without having to worry about shorting out to the metal case. Fun times. All right, I have a piece of plastic on the back of this to insulate it. Now what I'm going to do is I'm going to attach the breakout board with this bent over so I know its position, and then I can see how to fit on the Raspberry Pi A module. Felix is desoldering some parts. He should have those to me very soon. So my plan is I'm going to manually wire from the Raspberry Pi over to the module. Ah, here we go. Hot off the press. Stop the presses, who is that? All right, so this is from Adafruit. This is a 40-pin TFT breakout. Basically, it just gives you a bunch of solder points so you can attach things to a TFT screen. There is also a voltage booster on this board. Now it's for the LED backlight. The LED backlight on this runs at 21 volts, and we're gonna power this off 5. So we need a booster circuit to take the 5 volts this runs at and bump it up to a higher voltage such as 21. That's why we can see there's a little chip here, there's a coil, and that will give us our higher voltage. So what I'm gonna do is just make sure all of the flux cleaning is off of it. There are jumpers in the back where we can increase the current. However, the low current will be fine for this smaller LCD. So I'm going to pull out the header like this. I'm going to insert the flat flex ribbon cable into it, like so. Then once I know that it's in place, I can lay this down, and that tells me the optimum position to place this board. I'm going to try to place the Raspberry Pi over here on the side. So what I'm going to do is I'm going to make sure I have enough insulation. I'll probably just put some double-sided tape on the bottom of this board, lay it down and put it in place. And then when I solder into it, we should be okay because I have this insulating plastic layer, which should keep us from doing any short circuits. We'll actually attach the wires to this with it already in place. That way we know the exact length of wires that we need so we can keep everything nice and low. Got the LCD breakout board in place. Here is the depopulated Raspberry Pi A that Felix depopulated. See if we can slide this into place. Not too bad. It's got a little overhang, but I guess I'll have to live with it. What I'm gonna do is I'll probably set up the code using a regular Raspberry Pi A that has HDMI. I'll get everything set up on that, and then I'll make the changes to the blob file and bring it over here, and then it should run once I have everything set up. This is a super useful document found at elinux.org/Raspberry Pi BCM2835_GPIOs. It's basically a list of all the modes the Raspberry Pi GPIOs can go into. So they're not just GPIO, they have all sorts of functions. We have I2C, I2S audio, several SPI connections, and some PWM and also GPIO functions. The thing to look at here is the alt versions. See how we have alt 2 all here in brown? And that is the DPI interface, and that's what we're going to be using. Okay, now take a look at this. This is a depiction of how the GPIO could be mapped to an RGB color space, or RGB pixels, I should say. So the lesser one here, that's the one, I think we might use. That one only requires 16 IO, 16-bit color, which means you would have 65,535 different colors. That would probably be enough for a screen and playing retro video games. We could also wire up all 24, which would give us full 24-bit color, 888. I guess what we could do is I could just wire it up in 16-bit mode. That would give us the option of using the GPIO, even if we end up using the Teensy as a HID. Yeah, that would probably work. So what I need to do here is cross-reference the GPIO colors. See how we have 76543 of red, 76543.2 of green, and then of blue. So like bit 7 of red needs to connect GPIO 19. So using this list along with this sheet, I can cross-reference how to wire up the breakout board, and that will give us all of the colors. And then there's also the signal pulses, data sync, VSync, all that. And that is listed over here. So we see that pixel clock is GPIO 0, data enables GPIO 1, HSync, VSync is 2 and 3. So yeah, that gives us everything that we need to wire this all up. It's kind of like the secret key. So the Raspberry Pi can do a lot more than just HDMI. Okay, I have the green wire hooked up. I'm a little concerned because the wires on the vias have caused a bit of a bump, which is pushing against this ribbon cable, and that may prevent the ribbon cable from fully inserting into the slot. I guess we'll see if there's any visual artifacts, and if there are, we can fix it later. So what I'm going to do next is fan out these wires and cut it as short as it needs to be, and then attach the green wires to the various spots on the GPIO, going off of my list and the cross-reference I have on my computer. Okay, I'm using Win32 Disk Imager, which is a really handy program. I'm going to load the RetroPie image for 0 and Pi 1, and we're going to write it to, let's make sure this is correct, yep, F, which is the SD card. It's probably going to be a little slow since it's over the network, but it'll be all right. Now, I'm not going to just jump right into trying to boot it on this system. I want to use kind of a known working system, so I'll grab one of the intact Raspberry Pi A+s and hook it up to that first. That way I can make sure everything's working, I can compile the DTS file and then bring it over to this. So I'll get that set up while this image is copying. Our image is complete. Here's what's on the card. Now we have a config text file here. Let's open that. Okay, that's all well and good. And we also have this DTB file. Now this is a compiled file, although you can see some things in it, but it's mostly a compiled language. Now the DTB file is a device tree overlay blob file, which basically defines a lot of the functions of the Broadcom system on a chip processor. So when the system boots up, it looks at the config file and the DTB files, and it's like, oh, this is what I should do. Now we have a number of them here, although I don't see the A listed. Oh, hopefully this works. Otherwise, we're going to have to start over. But what we can do is we can modify these files in such a way to use the new interface. So we have to adjust the config file and the DTB file. But for starters, let's just see if this works. I'm going to unsafely eject it, which will make all of our Linux and Mac fans cringe. All right, let's see if it boots for starters. See how there's only one Raspberry on screen? That means it's the Raspberry Pi 1. Oh, mind blown. Well, it looks like RetroPie is booted up correctly. But once we get the image set up on the SD card, then we can start modifying it to work with our miniature LCD. On the Adafruit website, they have the config file for the 4.3-inch TFT, although we'll probably have to modify it a little bit. Yes, let's just copy this, and then we're going to go over into the SD card and take the config file into Notepad++. Notepad++ is awesome. We're going to go down to the bottom and add those items. And let's talk about what they do. Okay, so we're turning off the SPI bus and the I2C bus because those things use a GPIO, so they have to be off in order for us to use a GPIO as digital video output. And we're setting the frame buffer to 480 by 272, which is the size of the screen. We're enabling the DPI interface and also saying LCD equals 1. This part should be all right. That's basically saying that we're not using HDMI, we're using something else. This one here is a little important. This is basically a bunch of bitwise flags that we're setting. It'll probably boot with this, but we may need to tweak it. We can look into that a little bit later. And then down here at the bottom, this is the exact timing for the screen. So we have the horizontal size, then we have polarity, front porch, back porch, pulse width, vertical size, front porch, pulse width, back porch. Then we have frames per second, 60, the clock, which is 32 megahertz, and then this is the aspect ratio. Again, we'll probably tweak some of these things. That's basically how it's set up. So that's one of the things we have to do. All right, I found some stuff online. Apparently we call it pin A+. That's what we call the A+ model. So that's a good reference. So I'm going to take the DT blob file that we got from Adafruit, open it in Notepad, blah, 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 blah. All right, let's find B+. Okay, yeah. See how we have pins B+1, Pi 1, model B+, Rev 1, blah, blah, blah. All right, so let's just copy all of these. Actually, it'd probably be closer to the Pi 0, wouldn't it? Because there's nothing on it. So see how they have everything set as DPI? We need to change that. So let's go in and call it pins A+. We'll just copy paste that so we get it right. Pi A+, I hope. Okay, all right, so we don't need the last 8 lines. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So these can be turned back into regular GPIO, but what do we type for that? So it's going to type GPIO. Now, there's got to be something here. I need to look up the right thing to type. Basically, I took out the Pi 0. I put in the A+ because it's basically the same thing. Hey, I found something on GitHub. Function equals input termination, no polling. So we could probably also have built-in pull-ups. So that would be nice. So let's just copy this. Because that's what programming is all about. It's just about copying things. So let's set these all to inputs, so they could possibly be joysticks in the future. All right, all of those are inputs now. Guess the question is, will this work? Ha 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 ha. Okay, so let's save this blob file, A+, that hopefully will work. Let's get rid of that. Okay, so this is the blob file that we just saved. So I'm gonna copy this onto the boot directory. I said boot, not root, because it is labeled boot in Linux. So there's a DTS file, which is uncompiled, and a bin or DTP file, which is compiled. We haven't compiled it yet, which means we haven't changed our video settings yet. And that's on purpose because we need to be able to see what we're doing in order to do this next step. Potential security breach. Hey, that's great. It means that I'm connected to the Pi. Log in as Pi, super secure, password, Raspberry. Okay, CD, boot, all right. Okay, here are our files. So we have the config file and also we have the DTB file. Now we need to install something. We need to install a compiler for the DTS files. Sudo apt-get. I know this is kind of the realm of Felix. I guess the question here is, if I make a DT blob bin file, is it going to override all of these DTB files? I actually don't know, but we can try it. It won't actually destroy anything, and we can see what happens. All right, I installed device tree compiler. Now I can compile device tree files. Kind of obvious, right? All right, so our file is called dtblob.dts. Okay, so device tree compiler. The input is a DTS file, which I should probably type correctly. Output is a DTB file. You know, I had to type on computers all through the 80s. That's why I'm not really big into Linux. I'm like, I am so over typing. Okay, so we're gonna output a DT-blob bin, and then our input is DT-blob.dts. I think that's everything? Yeah, that should do it. Oh, I did an underscore instead of a hyphen. Oh, woe is me. Duplicate node name, video core pins A+. Did I miss it? Well, son of a beeswax. Okay, so apparently there was an A+ entry and I just completely missed it like a noob. Oh, look at that. All right, well, whatever. All right, so let's replace those. Okay, now let's save this. I'm gonna copy over the new file and try it again. Okay, I copied over the putty file. Hopefully it's right this time. See if we can log into the Pi. Maybe the Pi's kind of sleepy. Oh, there we go. Log in Pi. A party for an American hero, my son, the astronaut. Kirsten Dunst will be there. All right, let's see if this compiles. Whoa! Fatal error. Oh, I didn't sudo it. Zoop, bam. All right. Yeah, that's Linux for you. It's like, as long as I type sudo, it's okay. Okay, so the DTS file has been compiled into a bin file. I'm hoping that will override the other DTBs there. I could actually pull those out just so the system can't possibly boot to them. Yeah, anyway, I'm gonna do a proper shutdown and then we can change the config file and then see if this works. Okay, here's the config file. So let's go back into that Adafruit installation. Let's grab the code for the 4.3-inch TFT. Again, there's a few things on this that I'm gonna have to change, but for now, this will work. Okay, let's paste it in. Great. Actually, we should probably change the things right now while we're thinking about it. So see this number here? That is a decimal number. That's probably kind of an obvious statement, but it's set up in hex. So I'm gonna load up my calculator. I'm gonna put the number in decimal and then convert it to hex. Okay. Now, why did I do that, you might ask? Well, it's because everything is set up in hex for that. Let me show you. Where's the DTB blob file? Okay, check out this. This is a web page. Well, you probably recognize this. This is the alternate function stuff. And then, we're using the 565 mode. So we actually have to say that we're using 565 mode because the Adafruit code is set up to 888 mode, all right? So see how we have output format here? That is the lowest nibble of this number. That's weird. They have a 5 there. Because I think ours should be a 2. Interesting. Also, they don't have RGB order declared. Okay, well, I'm just going to type in what I think it should be. Okay, so we're going to turn this into a hex number, which we already did. So we go back over here. We have to put a, there we go. All right, boom, hex number. Okay, so we want mode 2, which is the 16-bit 565 color, and then we want RGB order type 1. Okay, everything else should still work. Let's save the config file. Let's close it. Okay, so we changed the bin file and we changed the config file. It should have the ability to work. I don't know if it will, but let's test it out. Hey, we got an image. Look at that. Oh, all right, so the reason I changed that hex number was because the system, it was set to a different color depth than what we were using. We're using, see this mode 2, and see how all the colors are compressed here. Whereas the Adafruit one, it's weird, they had it mode 5. That's strange. I thought they had it full 8-bit color. Well, whatever. Anyway, so we manually said that we wanted it to be DPI order RGB and then output format 565 config 1, which is how I wired it up earlier, just like that right there. So we changed that number. First, we changed it over into hex because then it makes more sense. Because see all this right here? This shows you how that magic number is put together. So the low nibble is the output format. Second nibble is RGB order. And then you have a bunch of bits. And so it's just easier to read as a hex number versus the decimal number that they had. Yeah, but it looks like it fired right up. So that's pretty cool. Okay, so to recap, we changed the config file to disable I2C and SPI. Then we put in some more commands to tell it, hey, here's some new timings for this LCD. Then we changed or created our own DT blob file with a custom setting for the A+ model. Actually, there is one more thing we should check with this. I'll probably have to reboot to do it. Okay, well, I looked it up. Apparently, good old Raspi GPIO does not work on the older Raspberry Pi A's, so I had to download an older program called Wiring Pi. Yeah, should still give us what we need. Basically, we just need to see what the pins are. Oh, that's kind of messy. Okay, a bunch of these are labeled Alt2. That's correct. That's the video interface. All right, we have in on 1618. That's correct. In on 22. In on 3840. In on 25, finally in on 22 and 27. Cool, so that tells us that our DTS file was compiled correctly. So we have basically the last 8 GPIO not used for video, but they can be used as general purpose input output. So we have that as a possible solution for our RetroPie input configuration. Or we could use a Teensy, but I just wanted to free up some IO just so we had the options. And yeah, it does reduce our color depth, but whatever, it's classic gaming. Spoiler warning, those old systems did not have 65,535 colors.
Okay, so I plugged the Teensy into the Raspberry Pi, and I'm going to power the Pi up. It's going to go through the boot process here. It's going to take a moment, but when it gets to it, it'll recognize that I've connected this Teensy as a joystick device and it'll ask me to configure it. So just wait for that to come up here. Okay, here we go. It's saying, welcome, one gamepad detected. Hold a button on your device to configure it. Press F4 at any time to quit. So I'm gonna just press a button. TNC serial keyboard, okay, so it's reading it. So it says press anything. I'm gonna press this. Okay, so assigning buttons to this thing is kind of weird. This gamepad configuration menu is kind of, I don't like it. It seemed to be arbitrarily responding to this USB controller here. So I think what we might need to do is go in and manually set this configuration in like a file somewhere, because I'm not getting very good results with this.
That's all we have for today. To recap, we connected the Raspberry Pi A Plus directly to an LCD and then used a blob file along with a config text file to drive it. So that's all well and good. We have a case design coming along as well, but now we need inputs, we need buttons. What should we do in the next episode, Felix?
So in the next episode, I'm going to be taking a look at the button matrix so we can get input into the system.
Yeah, I deliberately saved 8 GPIO lines. Maybe we can use those.
There are a few different ways to do it. I'm going to look for the best low-level solution.
So what do you think about this project so far? Have you ever made anything with a Raspberry Pi A+? What about RetroPie? Ever give that a shot? Let us know on the Element 14 community at element14.com/TBHS. We'll see you next time. It's not Evil Ted Danson, it's Matthew Modine.
He looks so much like Ted Danson. Come on.
Oh, so all old white guys look like Ted Danson, huh? I see how you
All
are.
old white guys with really white hair are Ted Danson.
I have a message. I don't believe you. I'm gonna have my psychic slug monster read your mind. Why don't you just read the message? No, I don't trust my own eyes. But Sluggy here, he saved my life during the war. Rebellions are built on hope. Why are you still here? What do you mean? You're of no more use to the story. But I'm a rebel. I rebel. If he was forced to build a Death Star, you know what?
It's like in Iron Giant, when Mansley launches the bomb, they were like, let's go after the guy that designed that bomb.
Yeah. I have this thing. I don't know what it does. I bought this thing of lettuce at Hy-Vee and it was like pathetically small. So I wonder what was up with that. Like, is it out of season or something? For your feet! You're fired. Squirrels in the park? A geezer playing chess? Oh, I still can't quite pull the trigger on a new computer. I don't know why. Probably because it costs lots of money. In this week's episode, we're going to resume working on the mini pinball machine. Now, we've shown in previous episodes we might have a target that gets hit and has a micro switch, but I was also thinking maybe like a rollover switch that's infrared. In a previous episode, I worked on a PCB design for the mini pinball game. So it turns out there were mistakes. So Felix, tell me about all the errors I made.
We don't have a real PCB. We just have laser paint.